Okay, so the last part of this section is called motion under influence of gravity. So motion under influence of gravity, which is good because that's exactly what is happening in the real world. So the equation that we're going to use is a formula from Galileo. You've probably heard of Galileo before. What Galileo found is that the position of an object, that's in the air relatively close to the Earth's surface is S naught plus V naught t minus 1/2 gt squared. Now what is the variable? The variable is t. S naught is the initial position. V naught is the initial velocity. And g is the force due to gravity. G is either going to be 9.8 meters per second or 32 feet per second. Sorry, feet per second squared. Depending on what our units are, it's going to be one of those two things. So what Galileo found is that the position of an object relative to the Earth, where it's either thrown or dropped, is S naught. S naught's the initial position. V naught t. V naught's the initial velocity. Minus 1/2 gt squared. G here is the force due to gravity. It's either going to be 9.8 meters per second squared, 32 feet per second squared, depending on what the units are in the problem. So let's do an example of how we're going to use this. Let's say a bullet is fired in the air vertically from the ground level. So from the ground level with initial velocity 200 meters per second. I want to find the bullet's maximum velocity and maximum height. Okay, so I have that a bullet is fired in the air vertically from the ground with the initial velocity being 200 meters per second. I want to find the bullet's maximum velocity and the maximum height. So let's use Galileo's formula to first find the position. If we're going to find the maximum height, remember we did that before. So to find the maximum height, what did we do? We found where was V of t 0, solve for t, and then plug it in S of t. Remember we did that before. The maximum height is going to be where was velocity 0, solve for t to find the time where that happened, plug it into S of t. To find the maximum velocity, we're going to look at the graph. We're going to graph it. We don't know how to find maximum velocity just yet. We're going to look at the graph for this one. Alright, so to find maximum height, we're going to have to figure out V of t. Well, to find V of t, we need to find S of t, because V of t was the derivative. So let's find S of t. So first step, we need to know what is S of t. Using Galileo's formula, we need to know what is S naught, what is V naught, and what is G. So with G was the force due to gravity. G is either 9.8 or 32. I need to know what was my problem being measured in. Was it meters or feet? Well, it told you in the problem the velocity was 200 meters per second, so that means that G was 9.8. So whenever the problem is with meters, it's going to be 9.8. Next, S naught. S naught was the initial position. So here it says the bullet is fired in the air from the ground. So what was the initial height if it's fired from the ground? Initial height would be 0 meters. Next, I need initial velocity. In the problem it told you the initial velocity is 200 meters per second. So using those three, this tells me that S of t is 0 plus 200t minus 1/2 times 9.8 t squared, which is 200t t minus 4.9 t squared. Okay, so there's our position. Remember, we're trying to find maximum height, and to do that we wanted to find where v of t was 0. So let's find v of t. V of t is going to be the derivative of position, so let's take the derivative, and I get 200 minus 9.8 t. Now go through our steps again. We're trying to solve where is v of t 0, solve for t, and then plug it into s of t. So let's set this equal to 0. 200 is 9.8 t. T here, let's go ahead and divide 200 divided by 9.8 is 20.41 seconds. So I found where v of t was 0. My v of t being 0 happened at 20.41 seconds. Now I'm going to take that and plug it into s of t. So s of 20.41 is going to be 200 times 20.41 minus 4.9, 20.41 squared. Let's plug that in our calculator. So I get 200 times 20.41 minus 4.9 times 20.41 squared, 2040.82, and this was in meters. So the max height is 2040.82 meters. Again, how did we find that? We found where was velocity equal to 0, solved that for t, plugged that t value into the position. So it's kind of like saying, where did the maximum height occur, and then what was the maximum height at that value. The next thing we needed to find was the maximum velocity. Let's look at the graph for that. Velocity was just a line. It was 200 minus 9.8 t. So it's a line that looks something like that. What is the largest value this function can take on? So on your y value here, what is the largest y value that I can attain? That would be 200. We'll figure out a little bit later how to do this a different way, but for now, look at your graph. The maximum velocity was 200 meters per second. Okay, let's do one more example using Galileo's formula. Let's find the velocity of an object that has been dropped off a 500-foot cliff at the moment it hits the ground. So we're trying to find the velocity of an object that has been dropped off a 500-foot cliff at the moment that it hits the ground. So let's kind of develop our step-by-step plan before we actually do anything. So we're looking for velocity of an object at a certain time. So we want v of t. The question is, what is this t? It's saying that the velocity when the object hits the ground. So what do you know about the position when the actual object hits the ground? When it hits the ground, the position is 0. So what I'm going to do is I'm going to figure out when is s of t equal to 0. I'm going to solve that for t. Then I'm going to plug that into v of t. So we're trying to find the velocity when an object hits the ground. So first we need to figure out when does that actually happen. So that's these first two steps. So when does it hit the ground? Then figure out what is the velocity at that moment. So that's our kind of game plan. Now let's actually implement it. First thing I want to do, when is s of t 0? Well, we don't have an equation for s of t, so I need to find it. Using Galileo's formula, I need to know what is s naught, what is v naught, and what is g. Let's start with g. G is either 9.8 or 32, depending on if my problem is in feet or meters. Here I have a 500-foot cliff, so this is going to be 32 feet per second squared. Next, what is my initial position or initial height? Well, my object being dropped off a 500-foot cliff So there's my initial height. Next, what is initial velocity? Well, it says an object is just dropped. So it's not thrown, it's not kicked or anything like that. So my initial velocity is just 0 feet per second. Had the object been thrown, then I would have had a different initial velocity, but it was just dropped, so just 0. So what does that make my position? It makes my position 500 plus 0 times t minus 1/2 32t squared. Simplify this just a little bit. 500 minus 16t squared. Alright, so go back to our game plan. What we wanted to do was find where s of t was equal to 0. That's going to tell me when it hit the ground. So I'm going to set this equal to 0. So 500 is 16t squared. I'm going to divide both sides by 16. Then I'm going to take the square root. So I get 5.6, let's say. And this was measured, I believe we decided this was going to be measured in seconds. Yeah, because the the gravity is always feet per second squared, so we're going to measure this in seconds. So I know that it hits the ground after 5.6 seconds. Next, we decided we were going to plug this into v of t, but I don't have an equation for v of t yet. So let's take the derivative of my s of t. So I get negative 32t. Lastly, plug in my value. So this will be negative 32 times 5.6. And I get negative 179.2 feet per second. So the velocity when this object hits the ground was about 180 feet per second. The negative meant that it was moving towards the ground. So again, what did we do? We were looking for the velocity when the object hit the ground. So the first question was, when did the object hit the ground? And that was found by finding where position was 0. Then we took that value and plugged it into velocity. So you got to be comfortable going between position and velocity. And just always ask yourself the question, if I'm looking for a velocity or position at a particular time, what's happening at that time? Is the velocity equal to 0? Is the position equal to 0? Is position equal to some other number? That'll help you solve for t. So a lot of these problems will be solving for t, so you got to kind of think about what's coming into play, position or velocity.